back to my YouTube channel. Today we have these two beautiful exponential equations to solve, where we have 2 to the power of x multiplied by 3 to the power of y equal to 12, and 2 to the power of y multiplied by 3 to the power of x equal to 18. And we have been given the domain of both x and y, and we are told that x and y are positive integers. So what will be the values of x and y? How do we approach this question? It is very simple. But I want you all to follow me and see how we solve these two beautiful exponential equations. So the first thing is to note down the two questions. We have 2 to the power of x multiplied by 3 to the power of y equal to 12. I am going to call this equation 1. And next, we have 2 to the power of y multiplied by 3 to the power of x equal to 18. I will call this equation 2. Now, what we're going to do, in order to solve these two problems successfully, two questions easily and successfully, what we need to do is to apply these two rules. First, we are going to multiply both equation 1 and equation 2, and we will also divide them. So first we say multiply equation 2 by equation 1. For the multiplication, there is no particular order, okay? So just for the purpose of this video or tutorial, I'm going to multiply equation 2 by equation 1. So I start with equation 2. So I have 2 to the power of x dot 3 to the power of x multiplied by 2 to the power of x dot 3 to the power of, this is 2 to the power of y, yes, and then I have this equal to 18 multiplied by 12. Okay, so what I need to do is to open up this bracket in this form, and so I have 2 to the power of y dot 3 to the power of x dot 2 to the power of x dot 3 to the power of y. So what I'm going to do is to bring same base together, okay? Same base, no, not same base. What I'm going to do is to bring same powers together, okay? So here I'm going to have 2, 1, 6. So I have 2. What I'm going to do is to bring 2 to the power of x dot 3 to the power of x, and then I have 2 to the power of y dot 2 to the power of y dot 2 to the power of 3 to the power of y equal to 2, 1, 6. So what I'm going to have now is to say so I have here, now we know that from indices, there's a law in indices that says if you have a to the power of m dot b to the power of m, then this will give us ab dot ab to the power of m. So we have same power but different bases, multiply both bases and take the common power. So we apply the same rule here. So it will be 2 to the power 2 dot 3 to the power of x. Then we have 2 dot 3 to the power of y equal to 2, 1, 6. And so this is the law I just quoted here. And so we have 2 dot 3 is 6. So we have 6 to the power of x dot 6 to the power of y equal to 2, 1, 6. And then I have 6 to the power of, if we apply this same law also, that's 6 to the power of x plus y. Since we have the same base, so we have, if we have a to the power of m dot a to the power of n. Then you have to apply this rule as that's the when the bases are multiplied and you have separate powers, different powers, so it becomes a. So this becomes a to the power of m plus n. Okay, so this is the second rule that we are going to be applying to this question. Okay, good. So we have, so this will give us, so 216 is 6 to the power of 3. 6 to the power of 3 is 216. And so since we have, this law also applies, if you have a to the power of x equal to a to the power of y, if the bases are equal, then it means the powers can also, the powers can be equated. So we have the bases will cancel out, so we have x plus y equal to 3. So I'm going to call this equation 3. So we have 3 different equations now. So from equations 1 and 2, we've been able to derive equation 3. Now we're going to go ahead and apply the division rule also. We divide equation 2 by equation 1. So now, since we have gotten equation 3, let's now go ahead and divide equation 2 by equation 1. So once we divide equation 2 by equation 1, this is what we're going to get. 2 to the power of y dot 3 to the power of x all over 2 to the power of x dot 3 to the power of y equal to 18 all over 12. So let's see what we have here. So we're going to be bringing, so what we're going to do is to rewrite this to give us 3 to the power of x dot, 3 to the power of x over 2 to the power of x dot 2 to the power of y over 3 to the power of y equal to 3 all over 2, because 6 here is 2, 6 here is 3. So you can see, figure out a pattern here. So what we are going to do now is to apply this exponential rule that says if you have a to the power of m over a to the power of n, then this becomes, since you have the same base, this is going to be, if we have, yes, we have the same power, let's say separate bases. So let's say this is base a to power n, and we have base b to power n. Then it becomes a over b to the power of n. Same power, different base. So we divide the two bases and then take a common power. Okay, so we're going to apply this rule here. So this now becomes 3 over 2 to the power of x dot 2 over 3 to the power of y equal to 3 over 2. So let me move on to the next page of the solution. So I'm going to have, so I'll start from where we left off. 3, sorry about that. So I have 3 over 2 to the power of x dot 2 over 3 to the power of y equal to 3 over 2. Now I want you to take note of this fact. Please take note of this for a fact. If we have a over b to the power of m is the same thing as b over a to the power of minus m. Yes. So when you can transform this, this is one of the rules of indices. I'm going to pin a video I made on the operating rules of indices in this video, okay? So you can go and watch it and familiarize yourself with the operating rules of indices. Okay, so this is what is going to happen. So here, since we have 3 over 2 as our answer, what I'm going to do is to change this using this rule. So we have 3 over 2 to the power of x dot. So this now becomes 3 over 2. And then the power y changes to negative. So we have 3 over 2 here. So we can see that the bases are equal. And then if we apply the same law, that a to the power of m dot a to the power of minus m n, that will be a to the power of m minus n. Okay? So we have this. So we have 3 over 2 to the power of x minus y equal to 3 over 2. Obviously, this is going to be power 1. And so, since the bases are equal, we can equate the exponential. That is the powers. So this will be equal to 1. So we are going to call this equation 4. Now I'm going to solve equation 3 and 4 to get the values of x and y. Okay? So solving equations 3 and 4. So I'm going to have equation 3 is x plus y equal to 3, and equation 4 is x minus y equal to 1. So once we apply the elimination method of solving a pair of simultaneous equations, we are going to have this value. So first, let's add up the two equations. So we have x plus x will give us 2x, and then plus y plus minus y will give us 0, and then 3 plus 1 will give us 4. So here we're going to have divide both sides of the equation by 2. So x will give us 2. Okay, so since x is 2, then what will be the value of y? So using equation 4, x minus y equal to 1. Value of x is 2, so it's going to be 2 minus y equal to 1. So this will imply that 2 minus 1 will be equal to y, and therefore 1 equal to y. So this implies that y equal to 1. Now, so at the end of the day, from the question, we can conclude by saying that x equal to 2 and then y equal to 1. So these are the solution to the equation, because we are told that x and y are positive integers. So we can check this off. So let me go ahead and check this off to see if the two values satisfy our original equation. The original equations are 2 to the power of x dot 3 to the power of y equal to 12. So if x is 2, so we have 2 to the power of 2 dot 3 to the power of 1 equal to 12. 2 to the power of 2 is 4. Multiplied by 3 to the power of 1 is 3. That's 12. And then, of course, the left-hand side equals right-hand side. And so that is correct. We can also check the second equation, which is the second equation is 2 to the power of y dot 3 to the power of x equal to 18. Y is 1. So you have 2 to the power of 1 dot 3 to the power of 2 equal to 18. So we have 2 multiplied by 9, 18, and so that means 18 equal to 18. So the value of x satisfies both equations, and so this is where we have come to the end of the solution. Please like my video. If you are here for the first time, please subscribe, and then of course give my video a thumbs up. Thank you very much. I see you in my next video.